Okay, Nam Shivaya, this is the DSKB Chavan, 19163. So today we are going to solve some from dynamic programming. It's Fibonacci army regarding Fibonacci series. There's some problem from code forces. So the question goes like, so King Kempsey's love Fibonacci numbers. He has several armies. Today he wants to make a new army for himself and he wants the number of men in his army to be the nth Fibonacci number. Given n, you should find the nth Fibonacci number. The set of Fibonacci numbers start with f of 0 equal to f of 1 equal to 1 for each I all greater than equal to 2, fi equal to fi minus 1 plus fi minus 2. So here basically the problem requires us to find out the nth number in the Fibonacci sequence. So where each number is the sum of two preceding ones starting from 1 and 1. So the input here basically consists of a single integer, which is the position of the desired number in the Fibonacci series, and the required output should be a single integer, which is the nth Fibonacci number. So here are the input and output that are desired. Here is the code. So here in the code, basically we use the dynamic programming to compute these Fibonacci numbers. So we break the problem into smaller subproblems and solve each subproblem only once and storing the solution in the table so that we can reuse it later. This can save us a lot of computation time. So in this case, we use the dynamic programming to compute the Fibonacci sequence by storing the values of the sequence in an array called fib. So we initialize the array with first two numbers of the sequence, fib of 0 equal to 0 and fib of 1 equal to 1, and used a loop to fill the remaining values of the array. So the key insight here is dynamic program here is we only need to compute each value of the sequence once, and then we can reuse it for the further calculations, for the future calculations. So instead of recursively computing the values of the Fibonacci series of each value n, we can compute them iteratively and store the values, the results in the array. So this allows us to avoid redundant computations and compute the nth Fibonacci number very efficiently. So here the code reads the value of n from standard input. We define an integer array fib of size n plus 1. We initialize and then we initialize the first two values of the array fib of 1 fib of 0 equal to 0 and fib of 1 equal to 1, where first two numbers are the Fibonacci sequence. We then use the loop to fill the remaining values of the array by using the recurrence relations, which is fib of I equal to fib of I minus 1 plus fib of I minus 2. This loop starts from I equal to 0 and goes up to n and calculating the value of fib of I for each value of I. So finally we print the output, like the output of the value fib of n, which is the nth Fibonacci number. So here are the outputs. So we have like first one, we gave the input as 1, we got the output 1. And second one, we have gave the input 2, we got the output 2. The desired outputs that have been given as example are same as the one that we got. Thank you.